Hello and welcome back. Today we're going to talk about 1.5 Tesla versus 3 Tesla. We're going to try to understand them from different perspectives. And I want to break them up into 4 different categories and kind of what separates them. And yes, this is just a high-level overview of the difference between 1.5 Tesla and 3T. There's more to it than this. But we're going to do our best to sum this up in a short duration of time. So if we look at 1.5 and 3 Tesla, the first component that we're going to look at is quality. And when we look at the quality of the images that we get, we notice that at 1.5, the T1 relaxation of tissues is shorter. So the T1 relaxation all right, and that matters. All right, so at 3T, we have our T1 relaxation times that are going to be longer. And this requires us to do some extra work, maybe run some different sequences, pulse sequences, in order to get around this obstacle, because it makes our T1 contrast not as nice. All right. We also notice that artifacts are going to be, we're going to have more artifacts at 3T than we do at 1.5T. And just to reiterate, we're going to have artifacts at all field strengths. All right? But as we increase our field strength, we notice that these artifacts increase as well. So we see more susceptibility artifacts. We see more of these blooming artifacts from metal in the patient. All right, so artifacts are lower at 1.5. Now, one of the benefits of using high field, or 3 Tesla versus 1.5, is the fact that we can go ahead and get more signal to noise in our image. And this we'll talk about in a second, offers us some benefits. All right, so we have an increased SNR. All right. Another part of this process and what makes 1.5 and 3T different is SAR, specific absorption rate, heating in our patient. And we see that there's lower SAR at lower field strengths. And as we increase our field strength, as we double our field strength from 1.5 to 3T, we increase our SAR by a squared relationship between field strength and SAR. So moving from 1.5 to 3T, we have increased SAR. Another thing that we have to consider is scanning, the scanning parameters. Now, if we are scanning at 1.5 Tesla versus 3 Tesla, we know that at 3T we get more signal to noise. And what that allows us to do is either one of 2 things. It allows us to either shorten our scan time, or it allows us to achieve higher resolution in the same period of time it would take us to run the same sequence at 1.5. We have more signal to work with, which means we can achieve higher resolution. All right. So those are the main benefits of 3T. It's the signal to noise ratio. We see this trend coming out. Now, when we also look at the factor of cost, there's a significant increase in cost as we move from 1.5T to 3T, and it was ballpark to me that on average it's around $1 million each Tesla you add to a scanner. I noticed that there's definitely going to be an increase in price going from 1.5 to 3T, so we have increased cost at 3T. So the benefit of 1.5 is decreased cost of the scanner. All right, so those are the major differences between 1.5 and 3T from an imaging standpoint. There's more out there. We just covered the high level. So I hope you found this helpful. Thank you for watching.